Hello and welcome back to Universe Sandbox. Today I have no clear idea what I want to do other than just mess around like I normally do. I guess what I could do is take, say, Proxima Centauri, which is much smaller than the Sun, actually the closest star to our solar system, which is gonna grab the Sun, because gravity, pull it out of its normal spot in the middle of everything and cause it to move, because the center of gravity is no longer just in the center of the Sun. It's now in the somewhere between them. If I had to guess, it would be like somewhere around here, maybe closer to the Sun, because the Sun is considerably much larger, so maybe here. Actually, I could add a binary center. Binary center. Yeah, it's like really close to the Sun. That's the center of gravity. Center of gravity. What things orbit around. They don't orbit the Sun. They orbit, oh boy. And that's what everything is orbiting around. It's not orbiting a particular star. It's orbiting the center of the gravitational pulls. Like, actually, let me get the binary center back. So let's say I wanted to add something that, oh, that's the wrong add. Rings. If I go to Saturn ring, binary center, it can be placed there. And since the Sun, oops, I let time go by way too quick. It was like a week. There we go, only a few minutes a second. The rings get dispersed, and most of which are going to get pulled into the Sun. What? Not how I think that should be playing out. There are people that hypothesize that the Sun is in a long binary orbit with another star because every major extinction event happens at roughly the same time. So I think there's a really distant smaller star in orbit around our Sun, which passes through this thing called the Oort cloud, which has a ton of comets in it. It rains them down into the solar system, and every once in a while one hits the Earth, causing a mass extinction event. Sometimes they're caused by outside sources like gamma ray bursts. Our Sun does not produce, nor would that hypothetical other star, because it is nowhere near big enough and that star would have to die. I want to see how long it takes the Sun to rip them away from Mercury. If this is, depending on how good the game is, the outer ring pieces are going to be pulled away faster than the inner ring pieces, because these are the closer you are to them, because the outer rings are obviously further from Mercury's gravity, so they move much slower and they're more susceptible to the Sun's influence over Mercury's. And obviously that depends on how big Mercury is, which is like 4 times the size of our moon. So it's not that big, so the outer pieces get stretched out because the Sun is obviously pulling on it much harder than Mercury is pulling on the ring pieces. And after a while, the outer ring pieces are going to get pulled out of Mercury's sphere of influence and then pulled in toward the Sun. Well, that piece doesn't count because it's being weird. And the ring is separated, and this is kind of the process of spaghettification, which is more commonly seen around black holes than anything. The ring is slowly being torn into like half. One half is being pulled closer to the Sun, one half is a little further away, and it'll all eventually settle into an orbit. It should be symmetrical since it was spherical. Well, yeah, circular. And over time, it begins to fill out a more distinct orbit around Mercury as the Sun gradually pulls away more and more pieces, but eventually you won't be able to grab stuff. So let's say I take Mercury's mass. Yeah, about 4.5 moons and double it to roughly 9. I'm just gonna round up because I'm lazy. Obviously, it's just going to consume all those ring particulates around it. Now it's going to take twice as long because gravity is twice as strong. That makes sense. So, I mean, they're still going to get pulled away because, gravity. So now, the sun is still trying its hardest, but it's not going to be as successful or noticeable at first. Able to hold on to more ring pieces, but it's more distorted because the sun's still tugging on them in one direction while Mercury's pulling them back in the other way. But eventually it kind of spirals out. It makes like a 5 or like an S shape. I don't know why. Let me double the mass again to 18 Earths, not Earths, moons. Obviously those ring pieces are gonna destruction, so I'm just gonna Control Z them out. There we go. And now the same thing will occur again, but again, it's still half the amount of time. At some point, Mercury is going to be able to get to a point where it can resist the sun's gravity and hold them into orbit. Like, kind of like this, but it won't lose any or won't lose its shape nearly as much. Now, if I were to say suddenly make this the size of 2 Earths, it's obviously, its gravitational influence is obviously going to be much stronger, so the ring is essentially going to collapse in on itself because they're moving at 1 speed, but then the mass got so much bigger, so it's not able to resist gravitational force, and then, yeah, all that. I find that weird when that happens. I don't know what causes it, but it's always fun to watch, but I'm going to control, you know, I'll leave it. They're like, oh, they're like zipping right past the planet. What is the speed of this thing? 34 kilometers a second, then obviously, as it gets further away, it's gonna get slower. That's how gravity works. Yeah, Mercury is able to keep its rings into its same shape. Because, you know, I think after a while it will still happen, but since the Earth, since its gravity is so strong, it'll take such a long time. Or like, yeah, actually it's been a while, nothing changed. Obviously, if I were just to suddenly make the mass 0.2 Earths, oh, that's why there's 2 decimals, that might cause a problem. Mercury's gravity is gonna get a lot weaker all of a sudden, so the ring is just gonna fly away. It's like I deleted it, but now the sun is gonna grab it. So instead of being like this sphere, it turns into an oval that turns where 1/2 falls closer than the other half. And it kind of creates like a mini asteroid belt. Let me just delete Mercury, because no one cares about Mercury. It's the smallest planet there is. Focus on the sun. This looks cooler. Rigel. That's a big boy star. And just launch it at 100 kilometers a second. Or 62 miles a second. Just go like there. That's a big star. Oh no, the lag. Throwing off a lot of heat. It's gonna pull the star, the sun, out of its spot. I think I moved it too slow. Uh-oh. Uh-oh. So now it's gonna have like this weird ring of I need to turn off the habitable zone and trails. Habitable zone trails. Actually, no, I can't. Actually, that's kind of cool. Leave trails on. Sagittarius A star can just go there. Boy, I'm not looking forward to this. I'm gonna slow it way down. Uh-oh. Raven. I need to get the name for it. View. Label. What I do? Uh-oh. Yeah. That's pretty much what I expected. I like how it gets narrower and narrower as everything gets closer to it, and it just consumes everything. The beauty of a black hole. Pretty much infinite gravity. Once inside and nothing will escape. On August 12, 2018, NASA launched the Parker Solar Probe as a spacecraft designed to study the sun's corona. The corona is essentially the atmosphere, the sun. This probe, named after the astrophysicist Eugene Parker, who first coined the term solar wind to describe the flow of energetic particles from the corona. It carries instruments to measure these particles in the sun's electromagnetic field. Basically, over the course of its 7-year mission, the Parker Solar Probe will orbit the sun 24 times. It will pass closely by the planet Venus 7 times, receiving gravity assist that will shrink the spacecraft's orbit, allowing it to get closer to the sun with each pass. The probe is expected to pass within 4 million miles, or 8.86 solar radii, of the sun's surface as its closest point. The simulation shows the initial projected path of the probe soon after its launch. It is important to note that this simulation is not perfect accurate for the full lifetime of the probe. Errors in the simulation are amplified by close encounters with Venus flyby. Will build up quickly after the first flyby, diverting the simulated probe from its planned real-life trajectory. The slower the simulation speed, the more realistic the probe's path will be. But there's no way to completely remove the error accumulation from the simulation. This is something we hope to improve on in the future. Basically what that says is, the faster the in-game time runs, it has to do more math quickly and within a second, so it's more likely to make an error. Say I was going at 12 hours a second, that would be twice as more accurate as going a day a second, because it's doing half the math in a second, so it's more likely to be right, I think, is what they're trying to say. So yeah, the probe was launched from the Earth, gets pulled in by the sun's gravity, orbit as it passes by Venus. It gets a gravity assist pushing it, which basically slowed it down and allowing it to pass further, closer to the sun. It'll do its orbit. Eventually, it'll pass by Venus 6 more times, allowing it to get even closer. Shoemaker Levy 9 collides with Jupiter in 1994. The comet D/1993 F2, also known as Shoemaker Levy 9, was discovered on March 24, 1993, and had recently been gravitationally captured by Jupiter and was the first comet to be observed orbiting a planet. In mid-1992, the comet had been ripped into fragments by Jupiter's gravity during a close approach. These fragments will collide with Jupiter 2 years later in mid-1994. So, pulled this comet into its orbit, then it tore it apart from its gravity, and they'll slam into Jupiter. And I don't know how many of you were alive. That's what caused those like dark spots in the atmosphere for like 2 weeks. All of the fragments hit the planet. Oh, yeah, there's last few. Actually, how many are there? Okay, I think that's enough tormenting the solar system for one day. If you enjoyed this video of Universe Sandbox, be sure to hit that like button, subscribe if you haven't been new to my channel. Change notification settings to all so you always know when I upload next. Peace.